Today, Ferran and I will present our final project, Sentiment to Signal, from retail investor text to market prediction signals. Our project asks whether the sentiment signal extracted from Chinese stock forum comments can become a useful signal for predicting future stock returns. We combine large language model assisted labeling with robot-based sentiment classification and several financial tests to evaluate the signal. Here's our roadmap. We first introduce the motivation and research gap. Then we explain our methodology, including sentiment labeling, model training, and sentiment index construction. And after that, we will present 3 experiments, including factor testing, regression analysis, and XGBoost prediction. Finally, we will summarize the findings and our potential next steps. And a guiding question is, can sentiment from noisy retail investor comments become a useful market signal? Chinese stock forums contains a large amount of real-time retail investor discussion, and these comments may capture optimism, panic, attention, and disagreement in the market. But the text is also very noisy at the same time. Investors often use slang, short expressions, sarcasm, and emotional language. For example, the first instance is clearly positive, while the second one is more sarcastic and harder to classify. So the main challenge is not only collecting the comments. The real challenge is turning messy text into a reliable quantitative signal that can be tested with financial data.
Previous research shows that financial sentiment can help stock prediction, especially when combined with models like BERT LSTM or BiLSTM. However, there are still several gaps. Some studies rely on small manually labeled datasets. Others use sentiment as a feature but do not clearly explain how the signal is constructed. Also, strong classification accuracy does not automatically mean the sentiment output is useful for prediction. Our project addresses this gap by building a complete pipeline, large language model enabling, robust classification, daily sentiment aggregation, and financial evaluation. The key idea is that we evaluate sentiment not only as an NLP task, but also a market signal. We focus on 3 research questions. First, can we reliably classify sentiment from noisy Chinese stock comments? Second, does the daily sentiment index predict future stock returns? Third, does sentiment improve machine learning prediction beyond price volume features? Our contributions follow these questions. We use Llama 3 to support scalable labeling, fine-tune Robota for Chinese financial comments, and aggregate command-level sentiment into stock day signals. So our main claim is cautious. Sentiment may provide modest, short-term, and sector-dependent market information. This slide shows our end-to-end pipeline. We start from East Money Stock Forum comments. After cleaning the text, we use Llama 3 to generate sentiment labels. These labels are then used to fine-tune a Robota classifier. The classifier produces sentiment probabilities for each comment. We then aggregate these probabilities by stock and by day to construct a daily sentiment index. Finally, we merge the sentiment index with 2 share price volume data and run 3 financial experiments: rank IC and quintile return test, regression with controls, and XGBoost prediction with and without sentiment.
Before testing financial value, we will first check whether the sentiment classifier is reliable enough for the task. Our Robota model reaches an accuracy of about 92.38%, and the F1 score is around 0.889, which suggests that the model can classify positive and negative sentiment reasonably well enough in the noisy Chinese stock comments environment. For example, the first line here is classified as positive, while the second one will be classified as negative. And of course, sarcasm and mixed emotion remain challenging, but overall, the model gives us a strong enough foundation to construct daily stock level sentiment signals.
After classification, we construct the daily sentiment index. Instead of using only positive or negative labels, we use model probabilities. For each comment, net sentiment equals positive probability minus negative probability. Then, for each stock day, we average the net sentiment across all comments. A higher value means the discussion is more optimistic, while a lower value means it is more negative. This gives us a structured financial variable. We can test whether today's sentiment predicts future returns over 1 day, 3-day, 5-day, and 10-day horizons. We can also use it as a feature in regression and XGBoost models. Experiment 1 tests whether sentiment works as a factor signal. We use rank IC, which measures whether stocks with higher sentiment rankings today also have higher future return rankings. In our sample results, rank IC is positive for the 1-day, 3-day, and 5-day horizons. The signal is strongest around the 3-day horizon and becomes weak by the 10-day horizon. This suggests that sentiment may have short-term predictive value, but the effect fades quickly. In other words, retail sentiment seems more useful for short horizon prediction than long horizon forecasting.
Experiment 2 asks whether sentiment adds explanatory power beyond traditional market variables. We run a regression where future return is explained by sentiment, current return, volume, and volatility. And the key variable here is the sentiment coefficient. In the sample result, the coefficient is positive and statistically significant. And the R squared also increased slightly after adding the sentiment index. In finance environment, return prediction usually has comparably lower R squared because stock returns are very noisy. So we are also not expecting sentiment to explain everything. The important point here is that sentiment adds some incremental information beyond the traditional price volume fact features.
Experiment 3 tests sentiment in an XGBoost prediction model. The task is to predict whether next day return is positive, and the baseline model uses price volume features only, while the enhanced model adds the sentiment index. This sample result shows a small average improvement in accuracy, F1 score, and AUC after adding sentiment. However, the effect differs across sectors. Sentiment helps more in finance, energy, and alcohol, but does not help in real estate and tech. This suggests that sentiment is not equally useful everywhere. Its value may depend on sector characteristic and retail investor attention.
Across the 3 experiments, we find a consistent pattern. Experiment 1 suggests that sentiment has modest short-term factor value. Experiment 2 shows that sentiment adds small but significant explanatory power. And experiment 3 shows that the sentiment can improve machine learning prediction, but mainly in some specific sectors. So our conclusion would be retail investor sentiment is not a magic predictor, but it can provide modest, short-term, and sector-dependent market information. There are also some limitations about our project. First of all, large language model labeling may contain quite a lot of noise. Also, binary sentiment may oversimplify the complex emotions. And sentiment may sometimes react to price changes instead of predicting them. Also, transaction costs are not included in any of our backtests. For some potential future steps, it is viable to future validate the classifier, expand the dataset, and test more sectors and horizons. And we can also consider multi-class labels such as uncertainty, panic, sarcasm, and disagreement. And that's all about our project. Here's the reference page, and thank you.